Greetings, everyone, and welcome back to another great episode of Weekly-CTI. I'm so glad to have you back, you cybersecurity psychopaths, because I know you're just frothing at the mouth going, what do you got for us, Daniel? I know you got something awesome. Well, actually, I kind of do. This is a very spicy meatball, as I like to say, right? It's got a lot of twists and turns, some clever maneuvering. We can learn a lot from this threat that we've got today. Let's dig in, shall we? We got this coming to us from Check Point. Gotta love the good folks over at Check Point, and this is their Check Point research blog. Very cool stuff. They have they're going to spotlight some malware coming from a Chinese APT called, wait for it, this is going to show you, here it is, Camaro Dragon. And they've got some malware called TinyNote. It's a backdoor, and it does all sorts of crazy, fun, interesting things that we can learn from as like red teamers and pen testers and all that. A lot of interesting things. So if you want to create an implant, there's a lot of useful information in today's episode that you can use to create your own implants, kind of model some of the stuff that you see here. Or if you're a defender, you probably want to see some of these techniques and how they're doing stuff so you can figure out what's a great way to defend against that kind of thing. Now, good news is that this seems to be a bit pointed, and we'll talk about that and like who their targets are. So unless you're in a very specific part of the world, but you never know. This APT, yes, they are specifically targeting a certain group or entities, but you never know when they turn their sights towards you, and you want to be ready for that, right? So, Malware Spotlight, Camaro Dragon's TinyNote backdoor. Now, let's get into some overview of Camaro Dragon. First of all, let's start right there, right out of the gate. Coolest APT name. You got to be right straight up with this. The other ones kind of leave me. Some of them are cool, I guess, but this one's pretty darn cool. I'm in my mind seeing a dragon driving a Camaro with its hair on fire, doing 140 miles an hour down the freeway, just reckless abandon, right? This is the picture I pull in my head. So let's start there. I mean, they still suck. Don't get me wrong, right? Doing horrible things and being horrible people, but they got a bitchin' name. It's just what it is. We can't say it's not, because it is. We know this. All right, moving on. They are Chinese spies, state-sponsored. Their activities overlap with another state-sponsored Chinese threat actor called Mustang Panda. And it's kind of funny. We've got Camaros, we've got Mustangs. Someone's into cars naming these APTs. Pandas do not instill fear into anybody. They should. They are a strong, beastful thing. And they will rip you a new hole if one gets a hold of you. So don't mess around. But just you think of them, they're cute, they're cuddly. Whereas Camaro Dragon, on the other hand, just sounds amazing. So there's that. So not nearly as cool of a name. They're obviously still dangerous, but we've seen some overlap with those two groups. So they might even either work together, work out of the same area. They're obviously like collaborating with each other. At least it seems that way. All right. So there's another cool thing that I say cool. Interesting is what I really mean about Camaro Dragon is that they use this MQsTTang backdoor, right? It is being used by them. It uses the MQTT Protocol for communication. This is an IoT communication protocol. Very interesting stuff. Very lightweight, very small footprint, because you're thinking IoT devices. You got to think embedded systems. So that's really cool. Actually, let's kind of jump in there. I did kind of pull some information up about this. This is from ESET. ESET right there. We Live Security. MQsTTang. Mustang Panda's latest backdoor treads new ground with QT and MQTT. And in here, if we scroll down just a little bit, there we go. Technical analysis. Give you a little bit of information here about the MQsTTang backdoor. It says it is a bare bones backdoor that allows the attacker, that you can't probably see, There you go. So you can read along with me. Allows the attacker to execute arbitrary commands on a victim's machine and get the output. Seems like what a backdoor is supposed to do. Even so, it does present some interesting characteristics. Chief among these is its use of the MQTT protocol for, they say CNC, I say C2, tomato, tomato, communications. So MQTT is typically used for communication between IoT devices and controllers. And the protocol hasn't been used in many public documented malware families. So this is kind of unique to the Mustang Panda and Camaro Dragon, right? APTs, respectively. Let's see here. It has been used. Okay, one such example is Chrysaor, also known as Pegasus. Well, there we go. We probably know a little bit of Pegasus, right? That's one that's probably hit our radar from time to time. From an attacker's perspective, one of MQTT's benefits is that it hides the rest of the infrastructure behind a broker. Thus, the compromised machine never communicates directly with the CNC server, as seen in Figure 2, blah, 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 right? This library depends on QT. Okay, then it starts talking about how it's using it. I did pull up MQTT. It says it is the standard for IoT messaging and is an OASIS standard messaging protocol for the Internet of Things. It is designed as an extremely lightweight publish-subscribe messaging transport that is ideal for connecting remote devices with a small code footprint and minimal network bandwidth. That seems like it was tailor-made for abuse, right? Small, lightweight, fast, not a big footprint. We like. It's nice. It's a nice. MQTT today is used in a wide variety of industries such as automotive, manufacturing, telecommunications, oil and gas, etc. Lions and tigers and bears. Oh my. So there you go. That is a little bit about MQTT, which is being used in that backdoor. Let's see here. Another really cool thing. Again, when I say cool, I mean interesting. Something I have to say is, when I read it, I was like, holy crap, that is smart. These people are smart, right? And what they're doing is they're using compromised consumer-grade TP-Link, like home routers, as anonymous C2 infrastructure. This is a stroke of brilliance. I mean, you just gotta I'm sorry, right? I'm sorry. You're horrible people. Stop. Man, you could really do some great things if you would just use your powers for good instead of evil, right? So come on over to the light, like Star Wars here. The light side. Yes, I know the power of the dark side, but the light side is better. Come over. That's where you should be, with us. All right. So what it does is it installs this, they find some, what do we say, vulnerable TP-Link routers. They install a malicious firmware, and in there is a custom implant called Horseshell, right? That's fun, isn't it? Come on back, because I went out there and found a little bit about Horseshell, and it is from Checkpoint as well. This is also a really good article. It's back from just about a month ago, I think, May. Not even a month ago, about half a month ago, May 16th. Booyah. Talks about Horseshell and a bit about it. It's a remote. It gives you remote shell, file transfer capabilities, and SOX tunneling. Again, I'm not going to read this because we got plenty to get through, and we're already almost 10 minutes into this thing. So let's move on, shall we? But definitely check out. I'll have that link. Don't you worry. You know me. I'm going to have you covered. All right. So that's through basically what we need to know about Camaro Dragon. Now let's shift our sights a little bit to the malware itself, TinyNote. Okay. So what do we need to know about TinyNote? It's a Golang based malware. This is all the executive summary. This is where I kind of pulled most of this stuff from, but I'll just kind of tell you what's going on and we'll hit the highlights when we need to, right? So Golang based malware, it is the first stage in stage of many, should I say, does basic target enumeration, also does basic command execution. It does this through PowerShell as well as Go routines. Fun. It is very redundancy focused, which means it has multiple persistency tasks built in. Like I want to have not just one way to maintain persistence, but many, right? I like persistence du jour, as it were. It talks to several different C2 servers, as well as uses different types of C2 command execution. Now, another interesting thing about this is kind of some of the naming convention that is used with the malware is meant to be very specific, and that specificity is foreign affairs related. Okay, so it uses this like in it. It talks about a PDF contacts list of invited diplomatic members. Right? There's another one that says note documents number 14, Tokyo from Embassy of Russia. Right? So obviously that's extremely pointed, very specific. That would be the kind of thing that might get the attention of their targets. And that's what they want. They want them to see that and go, oh, this is something I would want to know about. I would want to read into. If we can get our hands on this, would be great. And it's like, yeah, get your hands on it. It's awesome. It's not awesome for them. Okay. So let's talk a little bit about who this is actually targeting. Who are those people that would find that interesting? And that is the Southeast and East Asian regions, specifically the embassies in those regions. Right? Super fun. So I think Indonesia and Myanmar is named in this specific article. So just throw that out there. That's who they're kind of going after. At least that's who they believe they're going after based off of what they've seen so far. Okay, I got you. That's fine. It's built specifically also to bypass a antivirus system called SMAD-AV. Right? SMAD-AV is an Indonesian antivirus, and it is popular in Myanmar and Indonesia. Interesting, right? Is most likely used by the targets of the campaign, which makes sense. All right, so we've set the stage. We kind of understand a little bit about Camaro Dragon. We also understand a little bit about TinyNote. Let's move on, shall we? Next, what I want to do is kind of talk a bit more about this SMAD-AV evasion, because this is where it gets super fun. Let me find this area, and then I'll get you there. Here we go. SMAD-AV evasion. Let's check this. So when it first executes, I'm looking at if you're like, what are you looking at, Daniel? I actually need to pull this a little bit closer here, so it's kind of off the screen. Let's see here. It first executes a bypass SMAD-AV function. That's what it's called. And you can see that is located. Hi, do the thing. There it is. Right there, bypass SMAD-AV, right? And its purpose is to bypass SMAD-AV, as we know now is an Indonesian AV. Cool. Okay, but an interesting item which they point out here is that it says here that they've actually used SMAD-AV AV for their own purposes in previous operations. It says it forced its component SMAD-AV SMAD-AV protect 32.exe to sideload their malicious DLL. How about that? Talk about insult to injury, right? Why to kick a man while he's down? It's not cool, man. But hey, security hard. And I mean, I have never created my own antivirus solution, so I would assume that is a bit of a lift. So I'm not gonna hold them too close to the fire over this one. Building software is difficult, right? But we got to do our testing. Otherwise, these kind of things might happen. All right. So a little bit on how SMAD-AV works. Really interesting, actually. I'll give you the quick and the dirty on this. Is what it does is it checks for running processes, and then it sees, is there an associated window with that process, right? I want to, obviously, if you have a process running, there should be an open window that's running it. Right? Yes, we work in Windows in a lot of ways. So Windows, where's the window? If there's no window for a process, right? Obviously, it knows certain processes that are kind of services or background or whatever. But if you start something, there's usually an associated window with it. If it does not see a window. It flags that to the user and says, hey, saw this. FYI, didn't know if you were aware. And what would you like to do? Right? So it kind of gives you this pop-up. And the user then can say, you know, whatever, block this. I even think there might be an image of this. Is it in here? Yeah, it's right here. Let me show you this. Booyah. This is what the pop-up looked like, right? SMODAV detected a suspected program. Note Tokyo patched AV patch, whatever, blah, 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 right? It's recommended you choose block to block this program. So it's just kind of giving you a recommendation, but it's giving you, right? I can scan it, I can block it, or I can keep it and run it. Awesome. Right? So that is how that works. Now, that brings us back to TinyNote and where the cleverness begins, where you got to go, oh man, how do you think of this? You got a team of super smart people. I will give you that, right? Now, how it's clever. So its process creates a window without a window name. That's where it starts. I want to make sure that when we come back to the screen here, you're looking at the right thing. So let's see here. It creates a window and it uses the class name edit. Now, this is a default Windows class name. So if you look in the Windows API documentation or building Windows, that is something you can check out. But that's basically what you need to know about this, is that class name of edit is a default Windows class name. Now, this also, the TinyNote, as it were, it sets the X position to a very large number. And the X position is like where the window is relative to the right hand. I think it comes in from the right hand side, if I'm remembering correctly. So as you increase, it moves right. Right. So it sets this X position to a very large number, which basically says way over there. Just making sure that whatever display that you might be using, it's off the display. It's so far off to the right, you're not going to see it. Right. So there is a window, but the X position of it is way over to the right. That is my right. I don't know if that's your right, but that's my right. That's my right hand. It also sets the width and height of the window to 0. These are fun things we do. What else? It defines the window as a tool window, right? That's fun. And it does this by setting the WSEX tool window flag. This is in Windows documentation. You can go check that out. Again, it's all about if I want to use a window in Windows, I can set these flags about the window, right? This is all for people that are programming Windows applications. So it sets this WSEX tool window flag. Now, this is an intended flag for a floating toolbar. So if you need a floating toolbar, this is your go-to. Usually has, or not usually, it does have a shorter title bar than a normal window does. Also uses a smaller font by default. But here's where the fun begins. It does not appear in the taskbar, and wait for it, when you hit Alt F4, you know how when you hit, I'm sorry, not Alt F4, Alt Tab. Alt F4 would kill a window. Alt Tab, when you hit Alt Tab, what does it do in Windows, right? It shows you all the applications that you have running that's in the taskbar, and you can kind of cycle through that as you Alt Tab and pick the one you want, and it brings it up to the focus. Guess what? When you set that WSEX tool window flag, it does not show up in that little round robin, that lazy Susan of tasks that are happening. So it's very invisible. Now, if anything is using like, this software, this AV software, if it's using something like the is window visible API call or function, it sees it, but it's invisible to the user. And that is what's super, super crafty about this little piece of malware nastiness. Okay. So I did want to kind of show you that stuff. I'm sitting here talking about it. Booyah, there is some code here we can take a look at. And we can see, whoop, that's my bad there, people. There we go. We can see, right, main.main bypass SMODAV, right? And then we can see we've got int module handle, int v1, int window, window name, window class, or class name. And over here is like some comments for, well, it looks like base registers. Right, you got the ESP and the EBP. But down here, we got class name, syscall, string to UTF-16 PTR, is an integer, and there's edit. Aha. The window name, syscall, right? 00. We got the module handle of 0, window, and there's the create window X, right? So it does want to create a window and then sets it as WEX tool window, pulls the class name, pulls the window name, and then we have this Windows overlapped window. I'm assuming that is the X position. I'm not 100% on what's going on here. But there you go. And then you got this V1, which basically kind of does all this action. Goes, okay, I got all this stuff. I'm going to do it now. Booyah. Fires it off. So there you go. That's how it is super, super craft delicious when it comes to how it's getting away with all this hidden stuff. Whew, that's fun. Okay, now we figured out what's going on when it comes to SMODAV evasion or SMODAV. I don't know. I've been calling it SMODAV because whatever. I do what I want. It's my show, right? Let's start talking about the backdoor execution flow. This is something that's specifically called out in this article. So we're just going to hit the highlights, give you the technical details and pertinent information you need to get moving on this and to learn from this. What interesting things. So here we go. We got two modes of operation, right? First mode does persistence, PowerShell backdoor, and a malware, and they put in quotes, install or installation. And then the second mode is called the backdoor. Okay, one does kind of flow into the other. I didn't see how it was like it runs one or the other. Maybe if it had, because the second one runs after persistence. It's been, okay, we'll get there, right? But there you go. For me, it was just a little weird. Let's see here. Interesting things we need to know. So there we go. Let's start with this first mode. Basically, it checks to see if there is a string zip in the file path. And when I say that, the string zip, not that there is a zip file in the file path, but that there is a string that contains the characters ZIP in sequence. Does that make sense? Hopefully it will. Anyway, if not, cool. Continue. Moving on. Obviously, if there's probably an exit there, or it moves on. That's what it does. Now that I'm putting the pieces together, it moves on to the second mode, right? So, but if not, boom, we need to continue on. So it does creates a directory called it's out right out of the root of C. Then it's program data /robots. If that fails, then exit. But if you're successful, cool, keep moving. If it fails, you probably don't have the rights to do so, and therefore it doesn't really want to fuss with you. And it's just like, oh well, moving on to the next thing, right? So then it creates two scheduled tasks, test and test two. Creative. You spend all this time and effort making cool, badass malware, and then you use test and test two. I mean, come on, man. But whatever. These tasks retrieve PowerShell commands from the C2's robot.txt files. So basically out there in HTTP land, you got a robots.txt file. You can put whatever you like in it. They are widely used, and I've done it myself when I create my own malware to do fun things and play around and learn. You use a robot.txt file. It's always there. You just reach out, grab it. Hey, what's in there? A command. Yay, I'll run it. You can pull commands from that kind of thing. So interesting. These PowerShell commands retrieve and executes another PowerShell script for a third server, or from a third server. And this last payload is the PowerShell-based backdoor. Okay, and the C2 traffic is HTTP post, so it should be flying radar low. And then the next thing that happens is the malware copies itself. It uses 16 random characters, and it copies itself into a zip file, and it also creates a file path with the name .zip in it. Right? It's not a zip file. It is just a folder that has like some randomly created characters with .zip in it. It's not a zip file though. It just is a name. Blah, 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 .zip. And then right? So if we've reached that far, we're at that persistent stage because, booyah, it creates another copy of itself, right? And finally creates a scheduled task to execute from the copy, right? Now, let's see here. Let's get into the computer. You can kind of see some of this action happening. There you go. You see that robots, program data robots. There's test and test 2, pulling from robots.txt. And here is the PowerShell code, right? You see a scheduled task creates. Actually, I'm going to hit this because it's crazy. I know. Can we push this off? There we go. We'll just kind of scroll over. There you go. Scheduled task, create, tn test. So there's the name of it. There's when it wants to fire off, the minutes, 15 tr. So there's what it's going to run, which is PowerShell. We've got a variable, system.net web requests. We know that. Then it creates, oh, look, it's reaching out to the C2 for that robots.txt. Booyah. And then new object, system IO stream. So it's writing the file. Get response, grabs that response stream and writes it to that. And then it runs PowerShell. Bada bing, right? That's what we see. There's test 1. There's the same thing for test 2. Whoa, I went nuts. And yep, looking good there. And then here is the last one, grabbing that last, get that external here. And grab this, pull it out. And you see it's just running cmd.exe to run PowerShell. Start PowerShell, no profile, -c set alias. Let's see here. We got look, it's doing it against us. It's like a Matryoshka doll, right? Stuff inside of stuff. New object, net.web client, download string. Oh, look at that obfuscation going on there, man. It's not even a full thing. So it's creating different variables. V1, IEX, new object, right? This is part of the PowerShell command, but it's not all of it. Then there's V2, there's variable 2. And you'll notice there's the other part of, because it's got DAO, and then it's load string. That should be download string. But it's going to concatenate these things together and smash them together. And then you see HTTP. And then you have V3, variable 3, which is 103.159.132.91 / robots.txt. Then you have exe, right? And then look, concatenation, V1, V2, V3. You've got the whole thing smacked together, and then you can fire that off. And it does what it's supposed to do. Interesting. Gotta love good old obfuscations, right? And then as you can see, the final payload returned the lightweight PowerShell backdoor, which retrieves a list of commands from the C2, executes them with IEX invoke expression, and concatenates the outputs with N1W. Sends that back to the server in a post request. And here's what that looks like. Let me see here. I hate the overscroll for you, ladies and gents. So I guess I'm going to just throw this in here. We will full screen that. And I will do this. See if there's anything important in here. Windows state, native namespace, shadow, blah, 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 blah. So I guess I'll just leave you to check this out. We definitely want to pull things like URLs out of here, right? That's going to be good for us as far as IOC stuff goes. Results start. Looks like it's making some web request actions in here. There's that method of post, right? Reaching out to C2. And you notice it's grabbing the response. And it looks like it's in base 64, which if I look at my notes, it is. Actually, it's doing a bunch of stuff. So let's kind of get back to that, right? So this is the code that's making this all happen. But we need to get to part 2, right? Here's where I was telling you about the whole zip file, right? So it goes to 16 random characters.zip. It creates a file with the name .zip, but not a zip file. Oh, it is a zip file, right? Yes. Duh. Right? And then creates another copy of itself using the zip name as a folder, for example, right? randocharacters.zip, that's the folder name. It's not an actual zip. Both the file inside the zip and the unzipped copy of the file get the same randomly generated name. 5 randocharacters.exe, for example. It looks like this. Finally, the malware creates a scheduled task, like we talked before. There it is, creating scheduled task. Booyah. Persistence. Stewed to a perfection, right? All right, then that takes us to the second mode of the backdoor, right? This is pretty straightforward. Just kind of run through this quickly. We're on 30 minutes, so I want to start wrapping things up. This mode happens after the malware achieves persistence. That's why there's mode 1 or mode 2. If it sees zip, it knows I have reached persistence. I can just jump straight to mode 2 and is running from the zip path. Let's see here. Does some stuff. Malware enumerates the system for the following data and concatenates into one BA string. The current system username, current system home folder. Whoa. I am scroll crazy today. The system's network interfaces, which include the name, the MAC address, and the description of the interfaces. It creates all that. One big old string, right? So I can be big ace string. Read into that. Next, it encrypts the string using a simple XOR encryption with the encryption key of NASA, and then base 64 encodes the whole hodgepodge. This is one big ball of crazy, right? And then it picks a random C2 server out of 3 different C2 servers. We do have that here. And then constructs a GET request. Yay. So it's doing quite a lot here in this, what do we call this, a second mode, right? The encoded enumeration data is stored in a cookie called SSN. And then does some other stuff with headers. You've got a hostname header, which is going to pull from one of these 3. So you got Google, Facebook, Gstatic, and Twitter. It's got some randomized selection of user agent strings, which it could use and pick your poison there. And then the expected result from the server. So once it sends that GET request, it expects the server to respond with some JSON. And the JSON looks like this. Message, and then a base 64 encoded command is the message. Simple stuff. That's not like crazy stuff. That would be fairly easy to emulate if you were cooking something up for a red team engagement or red team engagement probably is where you would be using that kind of thing. So after the validation of the JSON, so it's like, hey, is this actually where I'm, what I'm supposed to be looking at? All right, let me decode that base 64 now that I know that it is, and I'll create a Go routine that executes the commands inside of that stuff. Boom. And then, hey, keep checking that old C2 server over and over and over and over again, as a loop does, right? That's what we like to call beaconing. Hey, you got anything for me? Hey, I'm here. You got anything for me? Hey, is there anything for me? That's what malware does, right? So, gets deep into attribution land at this point on why they believe that Mustang Panda and Camaro Dragon are Chinese APT based off of stuff that they've seen in the past, basically. Server IPs, targets, right? Victimology and lures are consistent with the latest Camaro Dragon campaign, so therefore we feel like this is Camaro Dragon. I get it, right? That makes sense. That the two would make sense. Including the activity associated with the MQsTTang backdoor. In addition, the actors also keep using a folder icon and a specific naming convention, right? The third C2 server, 5188.33.190, has a rather unique SSL certificates with alternate names of mail.mofa.gov.tw, so on and so forth. Another server with the same certificate is currently redirecting to the official infrastructure of the government of Taiwan, but likely was used for additional attacks by the threat actor. Conclusion. This is all bad. Do what you can, right? It is cool they talk about the utilization of Golang. And it's a Golang language not previously observed used in Camaro Dragon, so they're starting to update their skill set using a more contemporary language, right? I'm kind of on the Golang train my own self. I'm learning some Golang, building some tools to get proficient with it. At least I can use it and do things with it. I like it because it creates executables, and it's got a lot of really great cross compilation. It just does that very easily, and I like that about it. We got minimal lightweight functionality, embedded bypass of specific antivirus. So a lot of interesting stuff going on here. They continue to evolve, so we got to stay on top of that. So if you are in that Southeast Asian area of like Myanmar or wherever, honestly, they're probably not far behind others as well. So if you're in Myanmar or Indonesia, probably want to be on the lookout for this, especially if you're in the embassies specifically. Here's some IoCs for you to slap in your defenses. See if you can help, and you'll notice the Checkpoint customers remain protected. So if you're in there, you might want to contact the good folks at Checkpoint, see if you can't get spun up with some of their useful security tooling. So there you go, ladies and gentlemen. Camaro Dragon. Tell me that wasn't some cool stuff. Got to be honest, right? It's bad. We're all on the same page there. Wicked bad. But man, super neat, and I took a lot of great stuff from this. I learned some really cool obfuscations that I'm going to probably use in my own tooling and playing around in my own little sandbox. So yeah, I got some stuff from this. Hopefully you did as well. If you like what you saw, you know what to do. Find the like, the subscribe. Likes help spread the word about the series, so tell your friends. Do that by going like. Hey, add a comment down there. Let's talk about this thing. If you know something about this stuff or you've seen some interesting threats, send them my way so I can check that out. Maybe we make a weekly CTI episode about that. I also have a buy me a coffee. It's nice to get a buck or two from time to time so that I can, invest in cool tech or add something to the set or whatever the case is. Buy a t-shirt, and always try to wear fun t-shirts. So yeah, just giving back into the old show. I do thank you so much for watching, though. You're not compelled to do any of that stuff. If you don't feel like it, don't do it. If you liked it, though, I would appreciate it. And thanks a lot. That said, I'm going to call it a day. Thanks for watching yet again. And until the next weekly CTI, stay safe, everyone. Have a good one.